Welcome to our first clip on AWS best practices in the well-architected framework. We're going to follow the story of Comfy Cloud Clothing, a small online store that sells comfy t-shirts all over the world. Along the way, we'll learn about best practices to keep websites safe, fast, and cost-friendly in the cloud. You'll notice that I'm wearing this exclusive Comfy Cloud Clothing t-shirt. It's luxuriously soft, like I'm embraced in a warm, fluffy cloud. I hope you're as comfortable as I am. Let's dive on in. Meet Alex and Charlie, the brains behind Comfy Cloud Clothing. They're excited to share their t-shirt designs online, but they've never built a website in the cloud before. They want their website to be super safe for their customers, really fast to handle orders, and not cost too much money each month. So they turned to AWS best practices to figure out how to do this thing right. Best practices are like following a reliable recipe. Alex and Charlie found out that AWS has these recipes for building websites. If they follow them, they'll spend just the right amount of money, keep their store running quickly, and have a plan ready if something breaks. It's like wearing a seatbelt before you drive. It's a smart idea and keeps you safe from the start. AWS has something called the Well-Architected Framework, which is like a giant checklist of good ideas. It has 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. Think of these pillars like 6 strong friends who help Alex and Charlie build their t-shirt website the right way from day one. With these pillars, they can make sure their store doesn't crash, it stays secure, and doesn't run up a huge bill. Imagine Comfy Cloud Clothing gets really popular. People all around the world are buying t-shirts at once. If they didn't follow AWS best practices, their website might slow down or even crash. Best practices help them plan for busy times, keep their customers' information safe, and stop them from paying for things they don't actually need. Like Alex and Charlie, you can discover a lot of free guides on the AWS website, including special pages that show you how to build and how to keep your website strong. You can also read blogs from AWS experts and community members who share new tips. Anyone can do this. Just hop on the AWS website or search online for the Well-Architected Framework. Let's take a look at where you can find these AWS best practices and how to use them so Alex and Charlie's online store runs smoothly and stays safe. We'll start with AWS documentation, then head over to the AWS Well-Architected page, and we'll also explore the AWS Well-Architected tool in your AWS console. So get ready to log into your account if you want to follow along. Okay, I've now hopped over to the AWS docs. All you have to do is type into an address bar docs.aws.amazon.com. Here you'll find featured content including AWS services and guides. You'll see documentation on how to get started with AWS, product guides, and developer resources. We're going to head up and click on the AWS Architecture Center. The AWS Architecture Center provides reference architecture diagrams, vetted architecture solutions, well-architected best practices, patterns, icons, and more. If we click on AWS Well-Architected here, we're taken to another page where we can get started with the AWS Well-Architected tool. So I'm going to go ahead and click on AWS Well-Architected tool, and that brings us to this overview. And then I'm going to get started with the AWS WA tool. So if I click on this, we're going to be prompted to log in to our AWS account. I've already logged in, and if you're not brought to the AWS Well-Architected tool page, I'll go back to my home page, and all you have to do is start typing Well-Architected into the search bar, and go ahead and click on that. Now that we're in the AWS Well-Architected tool, we're going to go ahead and click on this orange button, Define Workload. So in the case of comfy cloud clothing, we're going to fill out some basic questions such as our name, description, review owner, and environment to get started. So for the name, I'm going to go ahead and type in comfy cloud clothing -prod. And then for the description, I'll just make something up here. An e-commerce platform for selling custom, luxuriously soft t-shirts built to demonstrate AWS best practices in scalability, security, and high availability. For the review owner, I'll put in Alex and Charlie with their email address. For the environment, we'll click on production. So this means the workload is live and serving real customers. For the regions, we'll click on AWS regions. We'll choose US East 1. Since the workload will be hosted entirely on AWS, we don't need to click this non-AWS regions. I'll scroll to the bottom here. The rest of this is optional. And click on Next. We can skip this Apply Profile section. And then we get to an Apply Lens section. And then we'll use the Lens catalog to keep AWS Well-Architected Framework selected. And then we'll click on Define Workload. So now we've successfully defined our workload. As you can see in the lenses, we haven't answered any of these questions yet, so I'm going to go ahead and click on AWS Well-Architected Framework. That will bring me to our overview, and if I click on Continue Reviewing, then it brings me to a page where it asks me questions about each of those 6 pillars we talked about, starting with operational excellence. So when you create or review a workload in this tool, you'll be asked questions that correspond to each of these pillars. For example, under the security pillar, you might see questions like, how do you protect your data at rest? Or how do you manage credentials and authentication? Each pillar has its own set of questions aiming to uncover any potential risks or improvements in that specific area. Finally, if we were to fill this all out, the tool would review our answers and give us improvement plans showing where we might need to tighten security, cut costs, or speed things up. And just to note, the AWS Well-Architected tool is free to use. You only pay for the underlying AWS resources that you use. Alright, so you've used the AWS Well-Architected tool, but sometimes you might want to hear from real people who've built stores or applications before. That's when you can check out AWS blogs, YouTube channels, or community forums. Everyone from big companies to small startups share their experiences, so if you have a question, you might find someone else who's already solved it. Remember the 6 pillars? Well, here they are. We're going to learn about each one in the AWS Well-Architected framework. Let's see how Alex and Charlie at Comfy Cloud Clothing use these to make their t-shirt store great. The first pillar is called Operational Excellence. This is all about how well you manage and automate your day-to-day tasks in the cloud. For Comfy Cloud Clothing, that means making sure new features roll out smoothly, problems get fixed fast, and that they implement small, reversible changes so they can continuously improve over time. Security is huge for any online business. This pillar makes sure you protect your data, control who can log in, and stay on guard against hackers. For Alex and Charlie, it means using things like secure passwords and encryption to keep t-shirt buyers' information private. Reliability means making sure your site doesn't go down when everyone rushes in for a big t-shirt sale. You plan for failures and have backups ready. If one server breaks, another one takes over. Your customers never notice a thing. Performance efficiency is all about using the right amount of power at the right time. If Comfy Cloud Clothing suddenly has a lot of shoppers, AWS can automatically add more computing power, and then shrink it back down later so they don't overpay. Cost optimization is all about not paying for things you don't need. Maybe you can turn off some servers when people aren't shopping. Using AWS's built-in tools, Alex and Charlie can figure out exactly how much everything costs and make smart decisions. Finally, sustainability focuses on using energy wisely and cutting down on waste. Maybe you pick a region powered by renewables or design your apps to use fewer resources. That way, comfy cloud clothing can help the planet while they help their customers. Now we're going to take a look at how Alex and Charlie at Comfy Cloud Clothing actually use these pillars in their e-commerce startup. We'll see some easy mistakes they could have made and how following the pillars saves the day. First, they want a smooth setup for new features. If they skip operational excellence, they might push changes without testing, leading to crashes. And for reliability, they might want to use at least 2 servers in different zones so the site stays online if one fails. A big mistake is launching with only one server. If it breaks, shoppers can't buy t-shirts. Next is security. Alex and Charlie make sure shoppers' credit card information and personal details stay safe. They use AWS Identity and Access Management to control who can access what, and they encrypt important data at rest. One common mistake is just writing your private keys in a text file. That's not a good idea. When they run a big t-shirt sale, traffic might skyrocket. If they rely on one fixed server size, the site can get super slow or even crash. Performance efficiency might mean using auto-scaling so more servers start up when lots of customers show up and then scale down later to save money. This will help keep response times quick. You don't want to have a fixed server size. The last 2 pillars are cost optimization and sustainability. First, Comfy Cloud Clothing wants to avoid paying for extra servers when nobody's shopping, so they watch usage closely. They also think about the planet by using efficient regions or smaller machines so they don't waste energy. One big oversight is letting a bunch of unused servers run 24/7, which is bad for your wallet and the earth. Before Alex and Charlie can build their t-shirt store in the cloud, they need to speak the language of AWS. In this clip, we'll learn about important words like region, availability zone, VPC, and subnet. Think of these as the building blocks of your cloud environment. We'll start with regions. A region is just a big location somewhere in the world where AWS has its data centers. Think of it like choosing a city to open up your t-shirt store. You pick the place that's closest to your biggest group of customers or meets your requirements. Inside each region are availability zones, which are like different neighborhoods. They have their own power and networking. If one neighborhood has a power outage, the others might still be fine. This helps your website stay up and running, even if a server in one availability zone, or AZ, fails. A VPC, or virtual private cloud, is like having your own fenced yard inside AWS. You decide which servers go inside and who can come in or go out. Alex and Charlie will use a VPC to keep their t-shirt store's infrastructure private and secure. Inside your VPC, you have subnets. Think of them like rooms in your house. A public subnet might have your website server that everyone can visit, and a private subnet might have a database that only you can enter. For Comfy Cloud Clothing, Alex and Charlie pick a region near most of their US customers to keep things speedy. They use 2 availability zones, so if one goes down, the other still works. They set up a public subnet for the website and a private subnet for their database, all inside a single VPC. What you don't want to do when building your cloud environment is to pick a region far away and wonder why your site feels slow. You also don't want to accidentally put your database in a public subnet. This will make it an easy target for hackers. And if you stick to one AZ, you risk downtime if that AZ fails. In this clip, we'll learn about scalability and high availability, 2 concepts that keep modern applications running smoothly. We'll see how Alex and Charlie at Comfy Cloud Clothing make sure their online t-shirt shop stays fast and reliable, even on busy sales days. When we talk about scalability, we mean adjusting how much computing power you have to match the number of visitors on your site. If hundreds of people show up, you need more power. If it's quiet, you scale down and save money. High availability is about staying online. even if one server goes down, so shoppers never see an error page. Let's talk about load balancers. Think of them like traffic controllers, directing shoppers to different servers. That way, no single server gets overwhelmed. If hundreds of people rush in to buy t-shirts, the load balancer sends them to whichever server is ready for more traffic. Auto-scaling is like hiring extra staff when your store is crowded and letting them go home when it's quiet. AWS keeps an eye on how busy your servers are. If they're working too hard, it spins up new servers automatically. Later, if traffic slows, it winds back down to save you money. Multi-AZ means you spread your servers across at least 2 different availability zones. If one zone has an outage, maybe a power failure, the other zone still keeps your website up. Load balancing plus auto-scaling across multiple AZs is the magic combination for a resilient setup. Now let's see how Infrastructure as Code, or IAC, helps Alex and Charlie at Comfy Cloud Clothing automate their setup. Think of IAC like a recipe. Once you write down the instructions, you can reuse it anytime. Infrastructure as Code means you describe what servers, networks, and databases you want in a simple text file, like writing down a list of ingredients. AWS then reads that list and builds exactly what you asked for. Once it's set up, there's a much lower risk of human error. Let's go through a few IAC tools. AWS CloudFormation is the official AWS tool for IAC. You write a template in YAML or JSON language, and CloudFormation spins up all your services like EC2, VPCs, and more. It's made by AWS, so it fits perfectly with other AWS services. Now, for each of these tools, I'm going to show you a code snippet for an EC2 instance resource. I won't be including providers, stacks, or additional configurations you would need to deploy these resources into AWS. I just want to show you how the code differs between tools. So here's an example of YAML code for a CloudFormation template that would deploy an EC2 instance. You can see the AMI or Amazon machine image that we want to use. The ID at the time of this filming is the Amazon Linux 2023 AMI ID. Terraform is another popular IAC tool created by a company called HashiCorp. It's great if you use different clouds, such as Google Cloud, Azure, or AWS. It works great for AWS alone as well. You write code in a language called HCL, or HashiCorp Configuration Language, which is human-readable and machine-friendly. Terraform makes it easier to manage your infrastructure across multiple platforms. Here's an example of HCL code for a Terraform template that would deploy an EC2 instance. As you can see, it's slightly different than our CloudFormation template. Next is AWS CDK. It's like a fancier layer on top of CloudFormation. Instead of writing YAML or JSON, you write code in TypeScript, Python, or other languages you might already use. The CDK turns your code into CloudFormation templates behind the scenes, so you still get all the benefits of AWS's native IAC. Here's an example of Python code for a CDK snippet that would deploy an EC2 instance. It looks quite a bit different from the first two examples because the AWS CDK has a construct library that you can integrate into your infrastructure. You just have to import it. So here, we're importing the EC2 part of the AWS CDK, then we're creating an EC2 instance. OpenTofu is a community-driven fork of Terraform, meaning it started from the same code, but it's now managed by open-source developers. It still uses the same style of templates in HashiCorp configuration language, so if you've tried Terraform, it's easy to pick up. OpenTofu is a relatively newer IAC tool. Here's an example of HCL code for an OpenTofu template that would deploy an EC2 instance. Notice that it looks identical to the Terraform template. The main difference with OpenTofu in terms of the code is that the provider registry name and CLI commands look a little different. For all of these code snippet examples, remember that in the real world, you typically add more resources such as security groups, a VPC, user data, and more. Why bother with all these tools? Well, if Alex and Charlie want to clone their t-shirt store infrastructure for a new region, they just run the same code again. They can also update or fix things quickly by changing the code and redeploying. It's like having a recipe that anyone on the team can follow. Some people try to build everything by hand in the AWS console. That might work for a small project, but it's easy to forget one setting or click a wrong button. IAC gives you repeatable deployments. If the t-shirt store suddenly grows and needs more servers in another region, it's just one template away. In this clip, we'll learn about the shared responsibility model. Basically, who does what when it comes to security in the AWS cloud. We'll see what AWS takes care of automatically and what you need to do yourself. The shared responsibility model means that AWS is in charge of protecting the actual data centers and networks while you decide how to lock down your own resources, like how you set passwords or encrypt data. Think of AWS as the landlord who secures the building and you as the tenant who locks your apartment door. A good way to remember who does what is that AWS is responsible for security of the cloud, while the customer is responsible for security in the cloud. AWS is responsible for security of the cloud, which means they secure the actual buildings, servers, and main network that run everything. If there's a power failure or someone tries to break into a data center, AWS handles it. They also patch their core services behind the scenes, like Amazon S3 or RDS, for example. Next, security in the cloud is up to you. That's things like installing the right security updates in your operating system, deciding how to encrypt your data, and making sure your security groups don't let everyone in. Once again, AWS is like the landlord who keeps the building safe, while you still lock your own apartment door. Let's take a look at a simple example of customers being responsible. Security groups are like having a guard at your server's front door. If you run a secure website, you typically open port 443 for HTTPS traffic so every visitor sees an encrypted page. Everything else stays closed. This way, people can safely shop for t-shirts and no one can sneak in through other ports. For the shared responsibility model, in Comfy Cloud Clothing's case, AWS takes care of the physical infrastructure, power, cooling, and data center security. Meanwhile, Alex and Charlie set security groups to allow only HTTPS traffic on port 443, and they could even turn on EBS or Elastic Block Store encryption so their t-shirt data remains inaccessible to unauthorized user, even if their server is compromised. This way, they meet their shared responsibility by adding their own security on top of AWS's foundation. A common mistake is assuming AWS handles all security for you. In reality, you must keep your software up to date and avoid storing passwords or secret keys in plain sight. AWS provides the secure foundation, but it's your responsibility to lock your own doors, like patching systems, managing keys, and setting strict security rules. Alright, let's wrap up everything we've learned. Networking basics, scalability, high availability, infrastructure as code, and the shared responsibility model, and see how they all fit together for Comfy Cloud Clothing. For Comfy Cloud Clothing, we saw how a VPC separates public and private resources. A load balancer plus auto-scaling handles traffic, and how IAC makes it easy to clone or update their environment. Under the shared responsibility model, AWS handles data centers, while Alex and Charlie manage security groups, encryption, and OS patches. Here's a quick rundown of the big ideas. We learned some AWS vocabulary like region, availability zone, and VPC, discovered how to keep our apps scalable and highly available via load balancers and auto-scaling, saw how to define everything with infrastructure as code for consistency, and figured out who does what under the shared responsibility model. Whether you're building an online store or a mobile app, the same rules apply. Create a solid network plan from day one. Use auto-scaling so your site doesn't crash under load. Rely on infrastructure as code for easy replication. And lock down your resources with the right security measures. If you want to explore more AWS topics, check out the various courses we have to offer. Many people aim for the AWS Solutions Architect Associate certification, which covers a lot of the topics we've touched on: VPCs, scaling, security, and more. The AWS Certified Cloud Practitioner is the best one to start with if you don't have a lot of experience in the cloud. Our hands-on labs are also super helpful to practice real deployments. Stay up to date with the official AWS docs, and don't forget about the well-architected tool to regularly check your setup. You can also join AWS user groups or forums where other developers share tips and troubleshoot problems together. Thanks for joining me, Charlie, and Alex on this comfy cloud clothing adventure. By combining strong network plans, auto-scaling, infrastructure as code, and the shared responsibility model, you'll build robust, secure apps for any project, t-shirt stores or beyond. Check out more labs, official AWS resources, and maybe take the next step toward certification. Happy cloud building, and see you on the next one.